Just a couple of days ago, Kim Kardashian asked a question about Three Eye Atlas and directed it to the acting administrator of NASA, Sean Duffy, and he immediately tweeted a reply in which he explained Three Eye Atlas and so forth. But on the same day, Congresswoman Anna Paulina Luna sent a letter to Sean Duffy asking NASA to release this data that is being held for over a month. No response so far. When I approached the principal investigator of HiRISE, no response. It doesn't make much sense for the politics of the day to sabotage the progress of science. We need this data in order to plan future observations of the object.
Mark December 19th, 2025. For the first time in recorded history, Three Eye Atlas appears to be on a trajectory edging closer to our planet than anyone expected. New data has stunned astronomers, suggesting the comet's path may be shifting ever so slightly toward Earth. No one can yet say what caused the deviation or if it could lead to a direct hit, but the uncertainty alone has scientists on edge. Around the globe, observatories are working non-stop, racing against time to refine their calculations before the comet's closest approach. If Three Eye Atlas is indeed heading for us, will we know soon enough to prepare? Telescopes across the globe are locked onto the object as it approaches. The Hubble Space Telescope, the James Webb Space Telescope, and countless ground-based observatories are now part of a coordinated effort to track every flicker of light, every deviation in its motion. What they're finding has baffled experts. The object, officially designated Three Eye Atlas, doesn't behave like a typical comet or asteroid. It's accelerating in ways that cannot be explained by gravity alone. For months, scientists assumed this was just another interstellar fragment drifting along a predictable trajectory, but as new measurements came in, that assumption began to collapse. The numbers simply don't add up. Harvard astrophysicist Avi Loeb was among the first to sound the alarm. His team's analysis revealed that Three Eye Atlas experienced what's known as non-gravitational acceleration, a subtle but measurable push that has no clear source. Normally, such a force would come from outgassing, when sunlight heats a comet's icy surface and causes jets of gas to shoot out, slightly altering its motion. But in this case, the data suggests something different. The acceleration wasn't random or chaotic. It had a distinct radial and transverse component, one pushing away from the sun and another nudging sideways, as if guided. Loeb's calculations indicated that the force was about 9/10 millionths of an astronomical unit per day squared in one direction, and roughly half that in another. Small numbers, yes, but in the vast precision of orbital mechanics, such deviations are enormous. Over time, they can mean millions of kilometers of difference, enough to shift a near miss into a potential impact. Even more puzzling was the comet's light signature. As Three Eye Atlas approached the sun, its brightness didn't increase in the gradual, predictable way most comets do. Instead, it brightened dramatically, following a steep power law with distance, suggesting an unusual reflective surface or rapid disintegration. But if it were just breaking apart, scientists expected to see a cloud of dust and debris trailing behind it. They didn't. What they saw instead was a compact, blue-tinged glow, bluer than sunlight itself, an extremely rare phenomenon. Blue light implies either an unusual composition, perhaps metal-rich, or a surface reflecting light unnaturally efficiently, like polished glass or even engineered material. For astronomers accustomed to dusty, red-tinged comet tails, this was unlike anything they had ever witnessed.
The implications are profound. A non-gravitational acceleration means something is actively propelling or pushing against the object. In natural cases, that could be sublimation of gases, but Three Eye Atlas's brightness and color suggest otherwise. Could this acceleration be artificial? Could it be driven by some internal mechanism or unknown process? Loeb, no stranger to controversy, raised a provocative possibility that Three Eye Atlas might not be a comet at all, but rather a technological artifact, an interstellar probe, or even a mothership releasing smaller vehicles. He pointed out that our solar system has now seen 3 confirmed interstellar visitors: Oumuamua in 2017, 2I Borisov in 2019, and now Three Eye Atlas. Each has been stranger than the last. Oumuamua's acceleration and lack of a visible tail first sparked debate about possible artificial origins. Now 3I Atlas is exhibiting eerily similar, though even more dramatic, behavior. According to Loeb, 3I Atlas reached its perihelion, its closest point to the Sun, on October 29, 2025. That date was crucial, he explained, because it's the point when any hidden mechanisms, natural or otherwise, would be most active. The intense solar radiation could trigger outgassing, break apart a fragile object, or, if the object were engineered, even power up a propulsion system. Loeb's theory draws on a real physical principle known as the Oberth effect, where a spacecraft can gain a tremendous burst of speed by firing its engines at the lowest point of its orbit, deep in a gravity well. If 3I Atlas were artificial, perihelion would be the perfect moment for it to accelerate or to deploy smaller devices. By late October, Loeb publicly suggested that 3I Atlas might act as a mothership, potentially releasing miniature probes as it passes near Earth. He called this the gift before Christmas. His reasoning was that if any interstellar craft were observing the solar system, it might take advantage of its trajectory near the inner planets to send out scouts. Loeb's team at the Galileo project began monitoring for unusual phenomena, fast-moving objects in the upper atmosphere, unexplained radar reflections, or anomalous radio bursts that could coincide with 3I Atlas's approach. The odds of anything truly artificial are still minuscule, but the data's peculiarities demand attention. After all, science advances by confronting anomalies, not ignoring them. The scientific community, however, remains deeply divided. Many researchers argue that 3I Atlas's behavior can still be explained by natural processes. Perhaps its composition is unusual. Maybe it's composed of volatile materials that sublime more violently than typical comet ices. Or perhaps it's surface fractured, exposing fresh material that reflects light differently. But even the skeptics admit the object is a riddle. Every new observation raises more questions than it answers. Why does it appear so blue? Why does its brightness curve so steep? And why does its acceleration seem too strong for standard outgassing models to reproduce? The mystery has left even seasoned astronomers uneasy. What worries some is not just what 3I Atlas is doing, but what it represents. If the data continues to deviate from predictions, it would mean our models of interstellar objects are incomplete or wrong. That has major implications for planetary defense. The key question now is whether its trajectory could shift enough to bring it dangerously close to Earth. At its expected closest approach, 3I Atlas should pass at roughly 269 million kilometers, comfortably far by cosmic standards. But the uncertainty introduced by non-gravitational acceleration complicates this picture. Small forces, acting over weeks or months, can change an orbit dramatically. In a worst-case scenario, even a tiny unaccounted push could mean millions of kilometers of deviation.
Astronomers are recalculating constantly, feeding in new observations, trying to constrain the object's future position. Each refinement narrows the margin of error, but it has yet to eliminate the unease. Meanwhile, the public has taken notice. Social media buzzes with speculation. Is it an alien craft, a natural comet behaving oddly, or a threat to Earth? News outlets pick up snippets of Loeb's interviews, framing them as dire warnings or extraordinary possibilities. Conspiracy forums erupt with theories about motherships, secret government tracking, and suppressed discoveries. But behind the noise, real scientists are genuinely wrestling with uncertainty. The truth is, no one fully understands 3I Atlas yet. Its light curve, its motion, its spectral signature all point to something new, something we've never seen before. As it moves inward through the solar system, 3I Atlas leaves a wake of speculation and fear. The International Asteroid Warning Network has launched coordinated campaigns to monitor it, bringing together space agencies, universities, and private observatories. Data from radio telescopes, infrared sensors, and optical cameras are being combined to paint a clearer picture. The James Webb Telescope is expected to capture detailed spectra when it nears its closest point, potentially revealing the object's composition and structure. If it turns out to contain compounds not found in typical comets, metals, synthetic alloys, or complex polymers, that would ignite one of the greatest discoveries in human history. For now, The debate centers on two main possibilities. The first is that 3I Atlas is a naturally formed interstellar comet, rich in exotic ices that sublimate powerfully as it warms. This would explain the acceleration, though not entirely the color or the smoothness of its light curve. The second is that it's an artificial object, perhaps a fragment or probe from an advanced civilization designed to harness starlight or magnetic fields for propulsion. In that case, its acceleration might not be caused by outgassing, but by some reflective or photonic process, like a solar sail. Loeb suggested before that Oumuamua could have been such a light sail, and he believes 3I Atlas's behavior may point in the same direction. If true, this would mark the first time humanity has directly observed technology from beyond our solar system. As December approaches, tension grows. Astronomers are racing to gather as much data as possible before 3I Atlas speeds away forever, out of reach for millennia. The object's brightness is increasing, making it visible even through moderate telescopes. Amateur astronomers report strange variations in its glow, brief flickers that might indicate tumbling or rotation. Some even claim to see brief separations in its structure, as if smaller fragments are detaching, lending weight to Loeb's mini-probe hypothesis. Scientists caution that these could be illusions caused by atmospheric distortion, but the pattern keeps reappearing. Something about 3I Atlas refuses to fit expectations. The psychological impact within the scientific community is unmistakable. Many researchers are hesitant to speak publicly, recalling how discussions around Oumuamua spiraled into controversy years ago. Yet, privately, more are admitting that 3I Atlas is pushing the boundaries of what they thought possible. There's a growing sense that whatever the final answer, this event will change how we view interstellar visitors forever. We used to think of comets as frozen leftovers from planetary formation. Now we might have to consider that some of them, just some, could be evidence of something more. The fear among some experts isn't necessarily that 3I Atlas will strike Earth, but that it's demonstrating forces we don't yet understand. If its trajectory can shift unpredictably, it challenges our confidence in tracking future interstellar objects. What if one day a similar body enters the solar system on a direct collision course, but our models fail to predict its true path because of hidden accelerations like this? The unknown is what terrifies scientists most. The sense that even with our technology and telescopes, the universe can still surprise us in ways we're not prepared for. As December 19 draws near, every new observation brings both excitement and dread. Will 3I Atlas simply glide past us, leaving behind a trail of data and wonder? Or will something extraordinary or catastrophic unfold? The window for the so-called gift before Christmas is narrow. If Loeb's predictions are right, this is when any accompanying probes or debris might pass near Earth. His Galileo project is preparing instruments to scan for anomalies, radar echoes, unexplained flashes in the upper atmosphere, or fast-moving aerial phenomena that could signal fragments or artifacts entering our skies. The world might not even recognize them for what they are until after the fact. And yet, amid all the speculation and fear, there's a deeper sense of awe. For the first time, humanity is not just observing interstellar objects, it's trying to interpret them, to understand their origins, to grasp their meaning. Whether 3I Atlas is a natural comet behaving strangely or a messenger from the stars, it's forcing us to confront our place in the cosmos. It reminds us that the universe is still full of mysteries, some of which may brush close to our world without warning. In the end, 3I Atlas may pass quietly, its secrets locked within, disappearing back into the cold darkness between the stars. Or it may leave behind data that rewrites the boundaries of science and perhaps of imagination itself. Until then, all we can do is watch, wait, and wonder. Because somewhere out there, racing silently through the void, an object from another star is heading our way. And this December, the world will be watching the skies, hoping the truth about 3I Atlas is revealed before it's too late.